So the topic for today is the imaginary number I. And previously, we said that we could not simplify square roots of negative numbers. So for example, we couldn't find the square root of negative 16. We would simply say that that was not real. Now we're going to learn that we can simplify this. But we're going to simplify not using real numbers, but using imaginary numbers. So now we have a whole new set of numbers available to us, and that is the set of imaginary numbers. So we're going to start by defining imaginary numbers and where they come from, and then we'll learn how to simplify some square roots that happen to involve imaginary numbers. So first of all, the imaginary number I helps us solve equations like x squared equals negative 1. Now, remember, if we took the square root of both sides, we would have the square root of negative 1 over here, and that is not a real number, and so we would say no real solutions. Well, now we are going to learn a way that we can solve this using imaginary numbers. So first of all, what is the imaginary number I? And this lowercase I is our imaginary number that we're going to be working with. And here's how it is defined. And I will specifically ask how it is defined on the test. And this is the answer I'm looking for. I equals the square root of negative 1. Okay? So that's what I is. Now, if you remember, if we go to this next box, I squared then is the square root of negative 1 squared, which is negative 1. All right? So I squared is negative 1. So guess what? I squared is now a real number. All right? So when we simplify I squared, we're going to be simplifying to a real number. All right, so first of all, let's go through some examples. We have the square root of negative 3. And the way that we're going to simplify this is using our product rule. What we're going to do is write negative 3 as the product of negative 1 times positive 3. So here we've got square root of negative 1 times the square root of positive 3. The square root of negative 1 is I. The square root of 3 can't be simplified, so this is I square roots of 3. It's as simple as that. So here we've got square root of negative 25, and before we said this is not real, and that is true. But how we're going to split this up using the product rule is into negative 1 times 25. So the square root of negative 25 equals the square root of negative 1 times the square root of 25. The square root of negative 1 is I. The square root of 21 or 25 is 5. That gives us I times 5. And we write it as 5I. Not I5, but 5I. All right, something interesting comes up in example C. In example C, I've got the square root of negative 4 times the square root of negative 25. And if we applied the product rule to this, we would multiply negative 4 times negative 25 and get positive 100. And the square root of that would be 10. Here's the issue. You cannot use the product property with two negatives under the radicand. All right? You can't. So I can't use the product rule with two negatives. What I have to do is simplify them separately. So the square root of negative 4 is actually the square root of negative 1 times the square root of 4. So split it up into the square root of negative 1 and the square root of 4. The square root of negative 1 is I. The square root of 4 is 2. So that's 2I. Let's go to negative 25. We already simplified this in the last example, and we said it was 5I. So now I'm going to multiply 2I times 5I. That gives me 10I squared. Here's the thing to remember. I squared equals -1. So you can't just leave I squared as I squared. You need to simplify it to -1. So this is 10 times -1, or -10. All right, let's take a look at example D. All right, in example D, we've got I square roots of 2 times I square roots of 3. And we're going to multiply these just like we've been multiplying our radical expressions previously. I'm going to multiply the I times the I, which is I squared. And then square root of 2 times square root of 3 using the product rule is the square root of 6. The thing to keep in mind here is this I squared, because I squared equals -1. So this is negative square root of 6 when it is simplified. All right, my last example. Now I, remember, is the square root of -1. So I is a radical. So just like we can't leave a square root sitting in the denominator, we cannot leave an I in the denominator. The way we get rid of it is we're going to multiply our expression by I over I, which is 1. All right? So when I multiply by I over I, in my numerator, I get 2 times I, which is 2I. In my denominator, I get 3I times I, which is 3I squared. Remember, can't leave I squared sitting there. I squared equals -1. So that makes my answer -2I over 3. Let's go to the next page, and we've got some more examples. Now, in example A, what I'm doing here is adding. So remember, when I add radicals, I am combining like terms. And guess what? That I is part of what needs to be like. So if you look at this, I've got I square roots of 2 and I square roots of 2. That's the part that needs to be the same. I've got one of them plus 3 of them gives me 4I square roots of 2. And there's nothing I can do to simplify that. All right, take a look at B. I've got the square root of -50. I want to use my product rule to simplify this. So remember, I can write 50 as 25 times 2. Well, also, let's bring out the -1. So I've got -1 times 25 times 2. So square root of -1 times square root of 25 times the square root of 2. So when I simplify these things, I've got an I times a 5, because the square root of 25 is 5, times the square root of 2. And the correct way to write these things multiplied is like this: 5I square root of 2. All right, example C is just like one we did on the last page. Oh, actually it's not, because it has a minus sign. What we need to do here, simplify both, okay? Because right now they're not like radicals. So square root of -16 is the square root of -1 times the square root of 16. The square root of 16 is 4. The square root of -1 is I. So this is 4I. The square root of -49 can be broken up into the square root of -1 times the square root of 49. The square root of 49 is 7. The square root of -1 is I. So we've got -7I. These are like terms. So all we're going to do is combine them. 4 minus 7 is -3. So this equals -3I. All right, the next example. I've got two issues here. First of all, I can simplify the square root of 32. The next thing, I've got a negative there, and finally, I've got a root in the denominator. So I want to see if I can simplify any of this. So first of all, I'm going to take a look at the square root of negative 32 and try to simplify this. So 32 is 16 times 2, and I can take the square root of 16. So let's split this up into the square root of negative 1 times the square root of 16 times the square root of 2. Okay? So my numerator is 15, and my denominator, I've got the square root of 16, which is 4, the square root of negative 1, which is I, so 4I, and then I've got the square root of 2. Now, I don't want to multiply by the square root of 2 over the square root of 2 because that's not sufficient to help me. What I need to get rid of is the I and the square root of 2. Okay? So what I'm going to multiply by to rationalize my denominator is I square roots of 2 over I square roots of 2. So in my numerator, this is going to give me 15I square roots of 2. In my denominator, I've got the square root of 2 times the square root of 2, which is 2, times 4 is 8. Then I've got I times I, which is I squared. But remember, I don't want to cancel my i's, because that's just going to give me an I in the denominator, and I can't leave I squared sitting here. Remember, I squared equals negative 1. So we're going to replace I squared with negative 1, and that's going to give us negative 15I square roots of 2 over 8. All right, very last one. I've got 6 over the square root of negative 2. We already know what we need to do here, but this is worked out for us, so you don't need to write it. First thing, take the square root of negative 2 and write it using imaginary numbers. So you're going to split this up into the square root of negative 1 times the square root of 2, which happens to be I square roots of 2. You need to get rid of the I and the square root of 2 in the denominator. So to rationalize, multiply by I square roots of 2 over I square roots of 2. In the numerator, this will give you 6I square roots of 2. In the denominator, square root of 2 times square root of 2 is 2. I times I is I squared. So I have 2I squared in the denominator. Remember, do not leave I squared sitting in the denominator. I squared equals negative 1. So here's what I've got. I carry over my 6I square roots of 2 in my numerator. This changes to negative 2 in my denominator, and I can actually cancel. 2 goes into itself once and into 6 3 times. Just bring my negative up. Negative 3I square roots of 2. The last thing we're going to do today is go back to something we learned last week, and that was about solving equations by taking the square root of both sides. The only difference is now if we get a solution that's not real, we don't have to say not real. We can give our solution in terms of imaginary numbers. So here's what I've got. I squared plus 121 equals 0. Subtract 121 from both sides. So you can get the x squared by itself. So x squared equals negative 121. Now you're going to square root both sides. The square root of x squared is x. And now I have the square root of negative 121. I'm going to split this up into the square root of negative 1 and the square root of positive 121. The square root of 121 is 11. The square root of negative 1 is I. And remember, this is going to give me two solutions. And many of you missed this on your homework last time. Do not miss this on the test. It's going to give you two solutions, positive 11i and negative 11i, two solutions. So let's take a look at B. The first thing I want to do is get all my x squareds together. So I'm going to subtract x squared on both sides. That gives me 3x squared equals negative 18. Let's get rid of that 3. So divide both sides by 3. So I have x squared all by itself. That's going to give me x squared equals negative 6. The next thing I'm going to do, take the square root of both sides. All right, the square root of x squared is x. The square root of negative 6 is what I have on the right-hand side. We're going to split this up into the square root of negative 1 and the square root of 6. Square root of 6 cannot be simplified. The square root of negative 1 is I, and remember, this is going to give you two solutions, positive I square roots of 6 and negative I square roots of 6. So let's take a look at our next example, C. First thing I want to do, I've got to get x squared by itself. So let's subtract 19 from both sides. And I've got 2x squared equals negative 16. I want that x squared by itself, so divide both sides by 2. That gives me x squared equals negative 8. The next thing I want to do is take the square root of both sides. All right? So here's what I've got. I've got an x on the left, and on the right-hand side I have two answers, plus or minus the square root of negative 8. But I do need to simplify this. So first of all, I'm going to pull out the square root of negative 1. Also, I can split up 8 into 4 and 2. So square root of 4 and the square root of 2. The square root of 4 is 2. So I have x equals plus or minus 2. The square root of negative 1 is I. And then I have the square root of 2. So x equals plus or minus 2i square roots of 2.